For section E, now this section consists of three case study-based questions of 4 marks each. And let's try to solve the first one, that is the 36th. It's given that a rectangular floor area can be completely tiled with 200 square tiles. And if the side length of each tile is increased by 1 unit, it would take now 128 tiles. Assuming the original length of each side of the tile be x units, we have to make the quadratic equation. Okay, suppose let's say this is the square tile and length of this square tile is x unit. Now this area of tile is equal to side into side, which gives us x square units. Okay, so this is x square units, and initially 200 square tiles can completely fill or tile rectangular area, so that means area of a rectangular floor should equal to 200 tiles multiplied by its area, which is equal to 200 x square. Now it's given that if side length of each tile is increased by 1 unit. Okay, now let's say this square, its side length is now increased by 1 unit, so that means the new side length is x plus 1. So new side length is x plus 1, and its area of this tile is now x plus 1 the whole square, that is side square. And now we can use only 128 tiles to cover the floor. So that means in this case, when side of the square tile is increased by 1 unit, the number of tiles are 128, and area of now the rectangular floor has to be tiled with only 128 tiles. So 128 into x plus 1 the whole square, like this the second set of equation, this is 1. Okay, so whatever are the number of tiles, the area of the floor remains the same. So that means the area in both these cases is the area of the rectangular floor. So I can write that from 1 and 2, 200 x square is equal to 128 into x plus 1 the whole square. And this is the answer for the first question, where we have formed a quadratic equation, and we have to write the quadratic equation in the standard form. So standard form means we have to write the equation in the form ax square plus bx plus c, which is the standard form of the quadratic equation. Okay, so I'm going to open up the bracket, this one. So this is 128 into a square plus b square plus 2ab. So this is 200 x square is equal to 128 x square plus 128 plus 128 into 2. A 2 is 16, 2 2 4 5, 2 256x. Okay, now I'm going to shift all these to the left hand side. 200x square minus 128x square minus 256x minus 128 is equal to 0. So 200 minus 128 is, this is 2772x square minus 256x minus 128 is equal to 0. And for all these three terms, common here is 8. So this is 8, 9x square, 8 3 are 24, 8 2 are 16, and 8 1 are 8, and 6 are is 48. So finally, my quadratic equation is 9x square minus 32x minus 16 is equal to 0. So this is the standard form of the quadratic equation, 9x square minus 32x minus 16 is equal to 0. Okay, so this is the quadratic equation that we have. Okay, moving on to the third one, we have to find the value of x. that is the length of the side of the tile using the factorization method. So we are going to solve this using the factorization method. And for this, A is 9 quotient x squared, B is minus 32, and C is minus 16. So A into C is 9 into minus 16, which is minus 9, 6 are is 54, 144. And the factors of 144 for which the product is 144 and the sum should be minus 32 is 36 and 4. So this is minus 36 and 4. So I can split up the middle term, that is 9x squared, and instead of minus 32x, I'm going to write minus 32x plus 4x minus 16. So minus 36 into 4 is minus 144, and minus 36 plus 4 is minus 32, which is the middle term. Okay, for these two terms, the common is 9x, so this is x minus 4, and here the common is 4x minus 4, which is equal to 0. Okay, so x minus 4 is common. This is 9x minus 4 is equal to 0. So that means either x minus 4 is 0 or either 9x minus 4 is 0, which gives us x is equal to 4 by 9. Okay, so we have got the values of x. So this is actually 9x plus 4. So 9x plus 4, which gives us x upon x is equal to minus 4 by 9. The length of the side cannot be negative, so we are going to reject this. And x is equal to 4 is the length of the squared tile. Okay, so question part 3 is done. And we are going to solve the OR section, which gives solve the quadratic equation for x using quadratic formula. So this is our quadratic equation, and if we have to solve this using quadratic formula, so by quadratic formula, x is equal to minus b plus minus root of b square minus 4ac by 2a. Let's put in the values. Minus of minus b is minus 32 plus minus root of b square, that is 32 square minus 4 into A. A is 9 and C is minus 16 upon 2 into A. So this is 2 into A. Okay. So this is by using we are using the quadratic formula. Okay, minus of minus 32 is plus 32. 32 square is 1024. Minus minus is plus. 9 fours are is 36. And 36, so 36 into 16 is 576. So this is 576 upon 2 into 9 is 18. So x is equal to 32 plus minus root of 1024 plus 576 is 6 plus 4 is 10. 7 plus 2 is 9 and 1 is 10. 5 plus 1 is 6. So this is 1600 by 18. And I can write x as 3200 plus minus root of 1600 is 40 upon 18. So that means either x is 32 plus 40 by 18 or x is equal to 32 minus 40 by 18. Now 32 plus 40 is 72 by 18. So this is 18 Those are is 72. So the value of x here is 4. And in this case, we are going to reject this because this is minus 40 minus 32 is minus 8 by 18. So this is 4 by 9. And this means the negative value, we are going to reject this. So our answer is x is equal to 4. And this is solved using the quadratic formula. Thank you for watching.